All right, guys, welcome to tonight's session. We are looking at exponent rules. You need to make sure you have a notepad and a pencil so you can write down what you are seeing on the screen. Tonight's lesson is entitled Exponent Rule Number 1. Again, make sure you've got that written down. Make sure you're ready to go. We're going to talk about exponents so that tomorrow we can explore in depth how we use this in math and where we see this. So, if you're ready, let's move on. Why do we use exponents? Okay, this is always a question. What is an exponent and why do we use it? Well, exponents are critical to math. They are the next step. When you were in kindergarten, you learned addition and subtraction. But now that we are moving into more advanced math, we have to learn more advanced terms. So the first thing, and you're going to want to write this down, when we started, we looked at something like this. You knew how to add 4 plus 4 plus 4, but there was a shortcut. Math is always about the shortcut, a shorter way to write it. And so we had 4 times 3, which is really the same as 4 plus 4 plus 4, which is 12. Again, multiplication is repeat addition. And so we learned this. This is critical. Multiplication is repeat addition. And we learned our multiplication tables, 3rd grade, 4th grade, 5th grade, 6th grade. You memorized all your multiplication tables. But now we've reached a point where we're getting into more advanced math, where we're no longer going to just repeat addition. We are going to start seeing terms that look like this. 4 to the 3rd. This is an exponent term, and exponents are repeat multiplication. So this is the big difference here. 4 times 3 is not the same as 4 to the 3rd. 4 times 3 means 4 plus 4 plus 4, which would be 12. Whereas 4 to the 3rd power means 4 times 4 times 4, which is 64. So this is critical. You're going to need to make sure you have this written down. The difference, multiplication and exponential terms. Multiplication represents repeat addition. Again, this is 3rd grade, 4th grade, 5th grade. We're moving into 8th grade, 9th grade, 10th grade, where we're going to see very large numbers. And the way we represent them is with repeat multiplication or exponential terms. So before we go any further, and keep your pencil ready, we need to write this down. How do we read or write a term with an exponent? Well, it's written always in this form, x to the y power. So it's important you have the x, which is your base or your original number, and that number is raised to a power, your y. And this tells you how many times to multiply it. So 5 to the 5th power would mean 5 times 5 times 5 times 5 times 5, or 5 fives. 6 to the 3rd power would mean 3 sixes, 6 times 6 times 6. So it's always written in this form, base and then exponent. So it's critical to understand this is the exponent, this is the base. When I talk about exponents, I'm talking about the little number on top, not the whole thing. This is a term. This is the exponent part of the term. Okay. Now, when would we use this? And there's ways we write this. So for instance, x to the 5th means x times x times x times x, 5 x's. And we call this simplified, and we call this expanded form. And this is really easy. It's really easy to see exactly what it is. Now, we're going to move forward a little bit. What if you had something like this? X to the 5th, y to the 3rd. This is one term. It could be written like this, or you could expand it out and write it like this. X times x times x times x times x, y times y times y. So you can see where exponents become a much simpler way to write these long terms. Now, what happens when we start combining terms? What happens when you get something like this? X to the 3rd power, y to the 2nd power, x to the 3rd power, y to the 4th power. Well, expand that out, and you would get x times x times x times y times y times x times x times all the way down. And again, I'm just writing x to the 3rd is 3 x's, y squared, 2 y's, x to the 3rd, 3 x's, y to the 4th, 4 y's. Well, I count. I have 6 x's and I have 6 y's, so I can simplify that more. X to the 6th, y to the 6th. So what I've done is I've established a part of my mathematical rule. This is the rule. It's starting, and hopefully you're seeing what we're doing here. And in case you don't, let's write another example. 3 squared times x times y squared times 3 times x cubed times y. So again, we can expand this all out, and here's what we see. 3 squared is 2 3s, and then 3 is 1 3. So altogether, we have 3 to the third power. We have an x and 3 more x's, which makes x to the fourth. We have a y squared and a y, which makes y to the third. So this is how exponents work. We can take them from very simple, one base and one exponent, to a little more complex, a base and exponent, a base and exponent with different bases. But then we can start getting real complicated, where we have the same bases, but all combined with multiplication, and we can simplify that further. And what we see is this gives us our first rule of exponents, and it's this: when you are multiplying exponents with the same base, you keep the base and you add the exponents. Okay, now remember what I talked about. The base and the exponent are two different parts. So an example of this: x to the third, y to the second, x to the second, y to the fourth. I have two x bases, one with a 3 and one with a 2, so it becomes x to the third plus 2. I have two y bases, y squared, and y to the fourth becomes y to the second plus 4, x to the fifth, y to the sixth. So this is our rule. When the bases are the same and there's multiplication, you simply add the exponents to get your final answer. Now, if this doesn't quite make sense, you can rewatch, go back, look at the examples that we gave, and hopefully this will start sticking in your brain. Tomorrow, we're going to spend some time exploring this in a more in-depth way. And again, if you ever have questions, you can email me right here at my email address. I will get that. Or you can go to my website, bit.ly/mathmasky, and look for more solutions and more practice. There are no questions. We're done for the night. Have a good one. Thanks. No, I need you to stop recording so I can chop this.